So far we've considered equilibrium pricing of risk in economies that face no aggregate risk, but where individuals do face individual risk. We'll now move to the case where not only do individuals face risk, but the economy as a whole faces risk. In particular, we'll assume that more bananas grow on the island in the rainy state than in the dry state. As a result, the Edgeworth box is no longer a square, but is now a rectangle with the longer side in the rainy state. The endowment outcome bundle E then again has individual 1 with more bananas in the rainy state than in a dry state, because individual 1 owns the part of the island where bananas grow very well in the rainy state. Were individual 1 to fully insure, he would again end up on the 45-degree line that emerges from his origin. But that 45-degree line now no longer connects the two corners of the box, because the box is no longer a square. Person 2 would similarly fully insure along the 45-degree line that emerges from her origin at the upper right-hand corner of the box. Person 2's 45-degree line no longer overlaps with person 1's 45-degree line because of the introduction of the aggregate risk into the economy, which causes the box to no longer be a square. As a result, we get the shaded green area between the two 45-degree lines. We can now ask whether the actuarially fair insurance terms could be equilibrium insurance terms in this economy, assuming that both individuals have state-independent preferences. Here we draw the insurance contract line that represents these actuarially fair insurance terms. When faced with a full menu of actuarially fair insurance contracts, individual 1 with state-independent preferences would choose to fully insure along his 45-degree line. He would therefore optimize at point A. If person 2 also has state-independent preferences, she would also want to fully insure under these contract terms, and would therefore choose point B on her 45-degree line as her optimal bundle. The actuarially fair insurance terms in panel A are clearly therefore not equilibrium insurance terms when both individuals have state-independent preferences. We therefore move to panel B to think about what the equilibrium insurance terms might look like in this economy with aggregate risk. At an equilibrium allocation, it must be the case that the indifference curves for the two individuals are tangent to one another, and the only place where that can ever happen is in the shaded green region. This is because above the shaded green region, person 1's indifference curves are steeper, which happens for person 2 below the shaded green region. The tangencies must therefore happen in the shaded green region, where both individuals have shallower indifference curves than they do on the 45-degree line. As a result, the equilibrium price line must be shallower than the actuarially fair price line graphed in panel A. Suppose person 1 optimizes at point C along this shallower price line. If this line represents equilibrium insurance contracts, then it must be that person 2 also optimizes at point C. In equilibrium, the bananas in the abundant state therefore become cheaper relative to the bananas in the scarce state as compared to the actuarially fair insurance terms from panel A. This should make sense. If bananas are abundant in the rainy state, and the individuals have state-independent preferences, then they're not as valuable in the rainy state as they are in the dry state. We thus see that while actuarially fair insurance terms emerge as the equilibrium terms of trade when there's no aggregate risk and the individuals have state-independent preferences, equilibrium pricing of risk will not be actuarially fair if the economy faces aggregate risk as it does in this graph, or if individuals have state-dependent preferences as they did in the previous graph.